Hello there. Chemistry Basics Part 2. Let's get started. So today I will explain molecules a bit more. A molecule is a non-metallic atom, so these, that share protons and make fun shapes. Because I work mostly in organic chemistry and biochemistry, the most important godlike atom of all is carbon. Ta-da! Carbon forms the basis of life. It will want to form 4 bonds. Why 4? I'll explain later. The goal isn't to show you how to deep fry a whole onion. I'm here to first chop said onion into small pieces, because it will be easier to digest. Atomic bonds are these lines in molecules. They are shared electrons between atoms and are what makes molecules molecules, instead of just random floating atoms. Atoms can have single bonds where they share 1 pair of electrons, double bonds where they share 2 pairs, or triple bonds where they share, you guessed it, 3 pairs. I hope your brain didn't just Baja Blast out of your left ear while hearing that. Carbon can do all these things. Hydrogen only wants 1 bond, so it can only form 1 bond. That bond can be with carbon, hydrogen itself, or other atoms. Oxygen wants to have 2 bonds, so it can either form 2 single bonds or 1 double bond. And nitrogen wants 3 bonds, so it has these possibilities. Now there are a lot more atoms than these 4, such as fluor, sulfur, phosphorus and silicon, but these 4 grades will form the basis for today. If you made molecules with only 30 carbon atoms, you could make more combination than there are atoms in the known universe. We don't need a lot of variety, but carbon is our flour, and this is my bakery, and my cookbook of pastries is infinitely large. Here we see a molecule. All atoms have their own letters. Carbon is C, hydrogen is H, oxygen is O, and nitrogen is N. Look at this molecule. Something fun. Carbon is so important that we can just leave it out. That's how you get drawings like these. Each corner is a carbon atom with hydrogen attached. The amount of hydrogen will be 4 minus the amount of bonds that you can actually see. This one has 3 hydrogens, this one has 2, and these ones, they have 0 hydrogens on the carbon. We can leave carbon out because it's chemically quite boring. It doesn't do anything. Most of the chemical work is done by nitrogen and oxygen and the other atoms that we do draw. Here we have alcohol before and after. And here's the active ingredient of cocaine before and after we remove the carbon and hydrogen from the drawing. Here's another fun molecule. Yes, it has sulfur in it. It's the molecule that gives grapefruit its flavor. You can put 1 drop of this substance in a lake and humans will be able to taste it. So, why do some atoms want bonds and others want more? Look at the periodic table. Do you see this lane right here? Those will not react. You can force them in a lab, but they're unstable, expensive, and I lose sleep over the weird bastards who made them. So they're kind of like children. Anyway, atoms want to look like these. This is not the real explanation. The real one is very complicated and it took me like 5 years of chemistry to get to that point, so yeah, this will do. Atoms are like onions. They have layers. They have a layer containing 2 spots for an electron at the middle, which is the K layer, a layer for 8, which is the L layer, another layer for 8 named N, and a layer for 8 called, well, you guessed it, the N layer. There are more layers, but nah. Hydrogen has 1 electron and 1 spare spot for an electron, and helium has 2 spots that are taken. Hydrogen will want to share its electron with another atom, so it has 2 electrons and thus looks like helium. Lithium, right under hydrogen, has 2 electrons in the K layer and 1 free electron in the L layer. Lithium wants to give its electron away in the L layer to look more like helium. It could in theory pick up 7 more electrons and look like neon, but that would be a lot of work and atoms are kind of lazy, they always take the easiest route. Carbon has 4 electrons in the L layer and wants 4 more to look like neon. Nitrogen has 5 electrons in the outer layer, so 2 of these 5 will form a couple together that won't be shared, but the other 3 will want to form 3 different couples of shared electrons, so it has 8 electrons in the outer layer. Oxygen has 6 electrons in the outer layer, and 4 of these will form a dimer of electrons, and the other 2 will be shared with other atoms. How many electrons does an atom want? You just count on the periodic table. Look. 1 electron, 2 electrons, 3, 4. Count electrons till you fall asleep. Or take a sip of a drink containing this molecule each time I say electron, and you will also fall asleep. Every horizontal row you go down in the periodic table, a new layer appears. The previous layer will be full, so if an atom has 3 electron spaces in the M layer, the K layer will have 2 electrons and the L layer will have 8. The sharing of electrons is what forms the bonds between atoms, which makes molecules. Anyway, that's enough for today. I hope you learned something or at least enjoyed yourself.